All right, so in this video, we're going to be adding the 1 in the fraction. So what's going to happen once we take our derivative here will be a fraction. So one of the techniques that we use is to take that 1 and the fraction, we add them together, and then hopefully they make a perfect square like we did in the previous video. So this is just another technique. And again, I like to pick problems that are not as simple. So we're going to be dealing with a natural log, which you'll see, it's a fun problem. All right, so the first thing we need to do is find f prime of x and then square it. So y prime is equal to 1 over 1 minus x squared, and then we got to multiply it by the inside, so that would be negative 2x. Just like that. All right, so we end up with negative 2x over 1 minus x squared. Now, we need to square that. So squaring it is just going to square everything. So that would be 4x squared and then 1 minus x squared. So let's write that. So that would be 4x squared, 1 minus x squared. Now, your temptation here is to actually multiply that out. You want to leave it alone, because like I said, we're going to add these fractions. And when you add fractions, you need a common denominator. The reason we don't want to break our common denominator apart is because we're going to be square rooting it. And you want to keep that as a nice perfect square so that when we square root it, it just cancels the square. All right, so now we're going to add 1 to it. And so this becomes 1 plus our 4x squared over 1 minus x squared squared. So now we just make our common denominator. So this would equal 1 minus x squared squared over 1 minus x squared squared plus 4x squared over 1 minus x squared squared. All right, so now we have our common denominator. We know that that would be 1 minus x squared squared. So now what we have to do is multiply the top one out so that we can add it to the 4x squared. So this is why we have to multiply it, is you need to add it to that 4x squared. So that would be just 1 minus x squared squared. So we can use our formula, or you can distribute it with FOIL or box method or whatever method you want. So minus 2x squared plus x to the 4th. So multiplying that out would give us this plus 4x squared. All right, now we just need to put it in descending. So this is x to the 4th plus 2x squared plus 1 over 1 minus x squared squared. Now our hope with the perfect square, so now when we square root it, like this, we want that top to be a nice perfect square. And so we know it is already. And if you don't see it, all you have to do is just guess. Well, we know that the beginning has to be x squared, because x squared times x squared is x to the 4th. And the last term has to be 1, so we put plus 1. And then we know it's positive because the middle term is positive. And we put the square on there. And then all you have to do is check it. All right, so x squared times x squared is x to the 4th. 1 times 1 is 1. And then for the middle term, we get x squared doubled. It checks perfectly. So now we can cancel the square root with the squares. And we get x squared plus 1 over 1 minus x squared. All right, so now we have our inside of our radical. And so we can go the integral from 0 to a half of x squared plus 1 over, I'm going to put it in descending because I know what's coming, like that. So we see our terms are the same. This is a partial, we can use partial fractions here, but this is a long division first. So first thing we're going to do is divide. So we have negative x squared plus 1. So we would multiply this by negative 1. That way we would get negative times a negative is a positive. So we end up with x squared minus 1. Change signs, don't forget that. Let's cancel and makes 2. So we can now rewrite this as integral from 0 to 1/2, negative 1, plus 2, and I'm going to put it back now as negative 1 minus x squared, like that. And we move on to the next one. So this is still partial fractions. We need it to be a nice 1 minus x, 1 plus x, which is what that is factored. That's 1 minus x, 1 plus x. I told you I picked a problem that's involved. It gives us a lot of steps so that you know that not each of these problems are going to be simple. Some are very complicated, and so you just have to sit there and keep picking at it. All right, so we know our 2 over 1 minus x squared is really 2 over 1 minus x, 1 plus x. So we would use a over 1 minus x plus b over 1 plus x. And we keep cracking away. All right, so a times 1 plus x, b times 1 minus x is a plus ax, b minus bx, and they have to add up to give us 2. So just the coefficients, the constants I mean. All right, so that means that would be 0x, like that. So a plus b is equal to 2, and a minus b is equal to 0. So the last one tells us a equals b. And so then we know, okay, well, if a is b, what number plus itself is equal to 2? 1 plus 1 is, yeah. So a is 1, b is 1. You can also plug it in, and that would be 2a. Divide by 2, a is 1. And then b would be 1. Same thing. So that's 1, and that's 1. And now we can continue breaking up our integral to our partial fractions. So we have negative 1 plus 1 over 1 minus x plus 1 over 1 plus x. And now it's ready to go. So this becomes negative x plus natural log of 1 minus x. Plus, ooh, there's a negative x there. So we need to change that to a negative because it would be 1 over this right here, right? So this would be 1 over 1 minus x times a negative 1. So we need the negative to cancel it. Remember, there's a negative here. So we need it here. Plus ln of 1 plus x from 1/2 to 0. Okay, so now we plug it in. Negative 1/2 minus ln 1 minus 1/2 plus ln 1 plus 1/2. All right, now on to the next one. That would be negative 0, which is just 0. And then ln of 1 minus 0 plus ln of 1 plus 0. No matter what, that's 0. That's ln of 1, which is 0. So that's ln of 1 is 0. ln of 1 is 0. We don't need those anymore. So it's just the first row. Negative 1/2 minus ln of 1/2. We can put that now in a parenthesis. Plus ln of 3/2. And then we can put those together. So negative 1/2 plus ln of 3/2 minus ln of 1/2. And then that's our division. You could even have just gone here. That's on the top. That's on the bottom. So we're going to end up with this 3/2 divided by 1/2, which is 3/2 times 2 over 1. They cancel, giving us 3. So it's a much nicer answer. Negative 1/2 plus ln of 3. And now we just cross our fingers because, my lord, that was a lot of work. Look at that, a full page. So all we have to do now is plug this one in and hope that all our work here is correct. And we know it is because, look, you got a perfect square. What's the odds of that happening? So we should know that this is correct. Let's plug it in our calculator, see what it gives us. So we plugged in our calculator, and that gave us our approximate answer. And then now we can just plug this in. And by the way, in some of the problems, they're going to ask you to use a calculator. And so what they're going to do is just want you to get to this point right here, plug it in the calculator. But you don't have to even get that far. All you have to do is really plug in that one into your integral and go for it. Saves you a little time. So you could even plug that one in to get your answer. But there you go.